I'm going to talk about artificial intelligence and what's enabled by hyperconnectivity through contextual computing. But first of all, let me define actually what is artificial intelligence. The thought has been defined in 1955 by John McCarthy at the Dartmouth conference. It's basically the science and engineering making intelligent machines. And our conception of basically AI is IBM's Deep Blue in the 90s, and then in the sci-fi would be R2-D2. And then also there's the evil version of artificial intelligence, which is Skynet. Basically, what are the popular approaches for AI at this stage? There are basically three different typical approaches. First one is called conventional AI. It relies on the computing power and how computers do Boolean evaluations and its number crunching abilities, so it can fast emulate all kinds of different scenarios. It's like what you see in personal interest. And then the next one will be statistical method. So it builds a gigantic database on past events and historical events, and then used its what happened in the past to predict what's going to happen in the future. It also actually relies on a huge amount of storage space and computing power. And last but not least is computational neural network. It tries to mimic how human brains work and how the neural systems work, and then try to eliminate some sort of unnecessary calculation to mimic the human brain. But all those three methods really require a huge amount of computing power and storage power, which is, even though it's cheaper now, but it's still very expensive if you're talking about the AI level of calculation. So this is not the best way to approach that, because let's say is on the left-hand side, you see a GPS. And we all know GPS tries to use some sort of AI to give you the best route, but it's just not there yet because it's missing a lot of contextual data. Then on the right-hand side is supposed to be a smart system, sprinkler system, and which is actually working, is actually when it's raining. Obviously, you do not need to water your garden when it's raining. So this is the failure of the AI at this stage, because it doesn't know what's happening right now. It only knows what happened in the past. And then we can say actually contextual data can add a lot of extra level of intelligence. For example, data like location, time, what did you have for breakfast, so have you had your lunch yet? And then there's actually insurance companies are pretty on the forefront of using contextual data. For example, Progressive, it actually tracks how you drive your car, then give you a different sort of a premium and a discount. Also, there are talks for health insurance providers to use contextual data as well. Has not been pushed out yet, but the talk is they can give you a very tailored premium. And if you follow their rules, for example, you need to quit smoking, you need to quit drinking. And then they will give you a device or use your mobile phone to say, oh, if you actually quit smoking or quit drinking. If you are in a pub, it probably will send you a text message say, hey, do not drink, otherwise your premium will go up by X%. So there's very strong talk about that's actually probably will happen as long as it clears the regulatory hurdles. And also, but then the contextual data creates very different key challenges. The first one is data privacy. When devices and companies collect a lot of data, how do they store this data, and how do they make sure that people do not have access to your personal data is very important. Then another one is data ownership. Who actually owns your data? Because you are the person who generated the data. Should you be giving a share of the profit if someone else is actually using your data to do that? There's definitely a lot of regulatory talks about this particular issue, especially in Europe. And there are a few very controversial rules has been passed in European countries. For example, the right to be forgotten. Basically, you can file a request to remove all your digital traces on the internet if you are a European resident. And then last but not least, the key challenge is actually the hyperconnectivity itself. A lot of the contextual data we see nowadays is sort of actually, it grows with the smartphone. You don't get any other contextual data that's not available through the smartphone. Basically, it's just the date, it's the location and time, etc. But if you talk about the industrial applications, there's a lot of data that you have to set up dedicated infrastructures so the data is available for someone else to use. And the key challenge here is the ROI is very, very hard to calculate at this stage, and the companies have been waiting, say, who is the frontier in this particular industry? Have they established a solid ROI so other firms will follow? So the infrastructure cost and actually coming up with different infrastructures for contextual data is the key challenge here. There are a few companies that's sort of like in this particular space. And the first one is Waze, which has been acquired by Google. What data it uses is basically time, location, traffic information, also user uploaded information, and your past behavior. For example, if you get into the car at 5 p.m., it will ask you, are you going home? Then basically, this is the infrastructure we talk about is actually that's available through your smartphone or other smart devices. And the next one is called T’15. It's a water leakage and utility water leakage detection company. And what data it utilizes is about pump. It's about valve values. It's the smart meters. It's the pressure sensors and the reservoir levels. So it can know is actually someone actually using the water or there's a leak in the pipe. So they can send someone out to actually fix the leak. And the challenge with this particular system is it's only available currently in very few European countries and Australia because they have the infrastructure ready to get all the data to a server room so they can analyze those data. And the United States and other countries do not have this particular infrastructure. And that's basically the ROI question we were talking about on the previous slide is people don't know if it will actually add value and they're waiting for others to do it first. And then last but not least is a startup based in Boston. It's called Beacons in Space. And what it does is it's like the beacon network that a lot of conventional centers and then a lot of indoor uses for basically locating where you are. Because GPS and Wi-Fi, it doesn't really work indoor and doesn't have a very accurate location if you want to use it indoor. And a lot of actually property owners have deployed their beacons, for example, convention centers, but it's actually very expensive to do so. And this particular startup, what it does is actually sort of puts all the beacon together, and all the beacon owners can rent you their beacon information. So all you need to do is basically call a API and then use this particular information and then pay a small fee to the beacon owners and to Beacons in Space. So this is sort of a different infrastructure, but also infrastructure company that creates some sort of, I would say, ROI calculation for people to deploy their own infrastructure and rent it out. And what are the key trends and implications? The first one is through contextual data, you no longer need a lot of computational data. So you can say a lot of smaller players can actually experiment with their own AI algorithm because it's getting cheaper because you don't need as much of storage and computational power. And then there will be new business models and new business opportunities. The first one will be basically providing the infrastructure needed for the contextual data. And also, how do you interact with different data and become a data broker, as per se. So because of all the regulatory problems, you probably do not want to handle the data yourself, and you want to outsource to someone. And data broker will be a very good business model as well. Also, the internal R&D is no longer your only AI research. You can actually outsource your R&D, or you can even acquire your product pipeline because smaller players are now able to do research and development. And there will be very good exit opportunities for smaller startups because this is the space that's actually getting really popular. And a lot of the big companies and strategic investors, they don't want to sort of like invest their human capital in this, but they actually only keep their own core business and then later decide to acquire a few companies. And we've seen a lot of smaller AI firms getting acquired, for example, Waze, and then T’15 is in negotiation with a few very big companies to getting acquired as well.